Okay, welcome everyone. This is the week 3 webinar for the stats class. And I want to let you know a few things. One, I don't want you to get scared. We have 2 chapters to do today, but in most people's opinion, chapter 4 and 5 combined is easier than chapter 3 by itself. So, don't get scared because you have 2 chapters because they're not too bad. And I think you'll agree as you see, as I go through it and as you start working on it. So let me share my desktop and I'll talk about the plan for today. Okay, so the plan today is we will start out with Q&A as always. I'm always happy to answer questions you might have. And I want to let you know the project is coming up. And in fact, if you go to the syllabus, I always look at that for due dates, but there's other ways of finding them too. It's due October 23rd. I know that's 20 days from now, but it'll go fast. So definitely you want to be thinking about it. So the project is coming up. So if you have questions about the project, I can help you out. If you have questions about probability or anything else, just let me know and I'll be happy to answer. You can say it or you can put it in the chat box. If it's in the chat box, people can't see it, but I can. Just let you know, or I mean, the YouTube can't see it. So anyway, I'm always happy to answer questions if you have any. And then we're going to be talking about discrete and continuous variables. So a discrete variable and a continuous variable, those are both quantitative variables and a very important part of this class. And we'll go over that. In fact, chapter 4 is all about discrete variables and chapter 5 is all about continuous variables. Then we'll get into probability distribution tables and the expected value in a standard deviation of a distribution. We'll talk about that and I'll talk about why it's important. Then we'll get into the binomial distribution, which is basically, it's a distribution of the number of yes versus no answers that could happen. We'll talk about that. Then we'll get into continuous distributions. And then the final distribution for today will be the uniform distribution. Basically, uniform means everything's the same. And that's kind of how it's going to be. All probabilities are the same. And we'll talk about the mean and the standard deviation of the uniform distribution with an example too. So that is the plan of the day. And let me know if you ever can't hear me or anything like that. I'm at home now I have a super microphone, so hopefully it'll work well. But again, please ask questions along the way, or right now would be a great time to ask questions. And I want to remind you a few things just to make sure that you stay on track, is that just because the due date for everything is Sunday does not mean you should start working on Sunday. That'll end up being a disaster. So make sure that you get most of this work done way before that, so that Sunday, if things go wrong, you can work on it. But don't wait till Sunday to start working on stuff. And then on Sunday, ask me for more time, because it's not going to happen. You need to ask me by Friday. So that's just a note. The other note is I graded your quiz, your exams, and some of you did fine. I noticed that your scores on the chapter assignments were much better than the scores in the than the exams. Which worries me a bit, because the chapter assignments, you get lots of chances. You can keep trying, but the exams, except for the last 2 questions, are the chapter assignments. All it does is it randomly grabs problems from the chapter assignments and it gives them to you. So it's not a good sign if you did like 15 out of 15 on the chapter assignments and then you got a 50% on the exam. So I mean, something's off. So make sure that you can answer in one shot the questions on the chapter assignments, so that when you get to the exams, you can do well on them. So it was just something I noticed, and the exams are worth a lot of points. So, take them seriously, which means make sure you can do the chapter assignments without having to redo things, because it won't go well for you on the exams. Any questions on that? Questions? The other thing I wanted to note is Some of you have already posted on the project discussion board on your project idea, which is wonderful. And I answered with some suggestions for adjustments. So I recommend, first thing, if you're one that posted, make sure you read my adjustments and make that happen. And if you haven't posted yet, you should also read my adjustments so that you get an idea of kind of what works and what can be improved upon, so that you have it, really good from the start, and it'll be better. And then post, and I'll either give you adjustments and say, oh, or I'll say, oh, I see you, saw the adjustments and now you've got it, even if it was a different person or a different group that posted. So again, take a look at that, look at other people's ideas, don't just copy their idea. You should have your own project, but make sure you look at my adjustments so that you get the idea of what works. Okay, because projects are a big part of what, coming up. It's less than 3 weeks before the project's due, and really you should be pretty much done in about 2 weeks or so, 2 weeks and a couple of days. That's the plan, at least with the draft. One more thing is I will not be having office hours on Wednesday. So I'm taking off Wednesday. I'll be offline Wednesday. So from basically Tuesday evening to Wednesday night, I'll be pretty much offline. And then I'll be back on Thursday. So stuff happens once in a while. So just let you know, I am taking a little time off. And then I'm back. But I check on weekends. I check almost every day. So any questions about anything? No questions? Okay, so if you don't have questions, and again, if you think about some new questions, just pop it in the chat box or ask them out loud. Either way, and I'm always happy to help out and answer them. One of the big points of these synchronized lectures is to be able to have conversations and be able to answer questions immediately when you ask them, so that you get your questions answered and you don't have to wait until I finish a different class or I wake up or whatever, which could be hours sometimes. So this way you get an immediate help. When would be a good time to post a prompt for project one? So you mean a prompt, you mean your survey question that your idea is? Is that what you mean by prompt? Good time would be, I'd say now, except you're listening to the lecture, but maybe as soon as the webinar's over, post it up. Okay. I may or may not haven't had dinner yet, so I may not get to it until tomorrow morning because I'm hungry, and I'll probably eat dinner right after this lecture. Hopefully you understand that, but I'll definitely get it by tomorrow morning. So post it tonight, and I'll reply by tomorrow morning. And the things that you definitely want to think about posting are, one is a survey question. Okay, so what words are you going to ask each person when you're saying the survey? That's important. The other is who your client is. The other is who your population is. Is it all students? Is it all college students? Is it all California residents? Is it all Americans? Is it everyone on Earth? Who is your population? That's important. The other is how you're going to collect your data. So are you going to use stratified sampling, or do you use cluster sampling? And if so, what's your process and your plan for collecting that data? And those are things that I'll definitely, help you with to make sure they work, because those are things you need to have before you go and collect the data. Is have to make sure that works. So hopefully that all works. Yeah. So again, when you post on the project one board, you post anytime, and then when I get to it, I'll look at it, and I don't take too long. Okay. If you post Tuesday night, it'll be Thursday when I'll reply, though. That's the only thing, because Wednesday I'm taking off. Okay. Any other questions before I jump into discrete variables? Okay, if there's no questions, let's talk about a discrete variable. So first thing is we're going to be looking at quantitative variables first. Quantitative means that when you ask a survey question, or you look at, whatever you're looking at to collect your data and writing your data down, the answer of the data value, it'll be a number. So quantitative means number. A discrete variable means that you can write down all the possible outcomes in a list. Sometimes in the list, you have to write ... to say the list keeps going on and on, but it's countable is what we call it. Okay. And if it is not countable, so it's a quantitative, but you can't write ... as a list of numbers where you say, well, yeah, those are the ones, then we call it a continuous variable. I do want to let you know the bad news and good news. The bad news is I'm not going to give you a full definition, the true rigorous definition of discrete and continuous. The good news is the reason is it's too hard, which means I don't require with a complete definition. I just want you to have an idea. Okay. But if you decide to be a math major like me, then you need to learn. But otherwise, you don't need to know the exact definition, just the idea of be able to recognize which ones look discrete and which ones look continuous. Okay. And for a discrete variable, a probability distribution can be created. And we're going to be looking at that. Okay. So one way, and this actually, I didn't learn until, believe it or not, I taught English until I taught English, but not regular English. I taught English as a foreign language when I was in Japan. And that's when I actually learned this question, this right here. And that is, if you ask a question and you have the words how many, then pretty much always that'll be a discrete variable. Whereas if you ask a question and it's how much, it'll usually be a continuous variable. So here, let me ask you a question, and I want to remind you, chat box is not put on YouTube. Let me give you some examples. So here's one. And my guess is no one will have the same answer as I have. And probably I'll let you answer too. And that is, how many siblings are in your family, including yourself? It'll be at least one, by the way, because you're in your family. No one's ever had the same answer that I have. Okay, so we're seeing a lot of answers. Let me put in the chat box. You'll probably be surprised. Okay, anyone surprised how I wrote 4.5? Okay, yeah, it sounds weird until you hear it. There's Laura. She's my half sister. Step. You know, and nowadays we have half brothers and half sisters, right? We share, we pretty much share one relative in a way. So it's like a stepsister kind of thing. Yeah. So 4.5 can happen. 4 1/3 cannot happen, by the way. You can't have a third of a brother. You can't have halves, but you can't have a third. So we got someone with a 2.5. Yeah, so that can happen. You know, and but you can definitely list all the possibilities. You could have 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5. And then you usually go ... because you see the pattern, but it's definitely something you can write in a table. Does that make sense? Even if it's got ... Any questions on that example? Okay, so that would definitely be a discrete variable. Okay, there are lots and lots of examples of discrete variables. Another one might be, I don't know, how many houses have you lived in? Or how many places have you lived in your lifetime? Okay, that's another one where you can't live in 0.3 places, right? I think I've lived in probably 12 places or something like that. Okay, so that's one that you can list all the possibilities. Any ideas? Let's see if you guys can come up with one of what a quantitative variable that is continuous. So what is it? Can you think of an example of a survey question where you would get a continuous variable? So that would be not discrete, but still quantitative. Any thoughts? There's lots and lots of examples of that too. And especially when you start with the word exactly, that helps sometimes too. Any thoughts? From a number from 1 to 10 that rates how happy you're feeling in the current moment. Okay, good. And then you better say it does not have to be an integer, because most people think they can only put integers. Yeah, it doesn't have to be an integer. Any number from 1 to 10 on how happy you're feeling. That sounds good. Where it doesn't have to be an integer. It could be, for example, if you're not in a good mood, maybe here. Can you see my shirt? That's not an integer. Hopefully you can all recognize what that is. That's pi, 3.141592657, et cetera, et cetera, et cetera. Okay, so that would be a great example. Okay. Another one might be is exactly how much do you weigh? I was actually asked that today. I got my flu shot and my blood check, which they do at the college. They give me $50, 50 bucks just to do it, which is kind of nice instead of paying. Okay, yeah, and it'd be exactly how old you are. Does that make sense? So if you're expecting everyone around in the nearest year, then that wouldn't be. But if you're saying exactly how old you are, then that would be a continuous variable. Because I am, 56.1375 years old. Okay, does that make sense? Okay, so that's discrete and continuous, and it's important to understand the two. So now we're going to work with discrete variables. All right, so here's an example. Okay, a car salesperson gives out a $10 gift to every customer who test drives a car. That kind of stuff happens a lot in sales, right? Let's suppose 12% of all customers who test drive a car purchase the base model of the car, resulting in a $200 commission for the salesperson. 8% of all customers who test drive a car purchase the deluxe model of the car, resulting in a $300 commission for the salesperson. Okay, and what we want to look at is profit. All right, so we want to look at the profit. So a question we might have is, what are the possibilities for the profit for this particular example? And maybe I'll give you a hint. Profit is revenue minus cost. You don't know business, but that's what it is. Let's see if you can guess. And she really wants you to know. Okay, expected we'll get in a little bit. We're not quite ready for expected yet. I just want to see the list of possible profits. We will get to the expected, but I'm doing that after, because we don't even know what that is yet. So what are the possible profits? I don't see y'all jumping in. Okay, good. One of the possible profits is 190, because if the person purchases a base model, they get $200, but they paid $10 for that gift. So that's 190. So I'm going to put 190 in this table. What's another possible profit? 290, yeah, because if the person bought the deluxe model, then the salesperson gets $290. Are there any others? Yeah, -10, because most people don't buy a car. And then they get the $10 gift certificate and they go home. And guess what? The salesperson just had to give 10 bucks and doesn't get anything out of it. So -10 could happen also. Any questions on that? All right, now we need the probabilities, and these are all given, but one thing you have to know how to do, this is kind of a requirement, is to know how to take percentages and turn them into decimals. So 12%, you always want to write decimals when you're putting in any calculators, is 0.12. Okay, 8% is 0.08. So now we need to find out, how about the probability of gaining -$10 or losing 10 bucks, profiting -10? How do we get that probability? Any thoughts? Yeah. So if you add up the three probabilities, that's 100% chance, right? Something's going to happen, which means that if you take 100% and you subtract 12% and then subtract 8 more percent, that's subtracting 20%, which is 80%, which is 0.8. Any questions? Any questions on creating a probability distribution table? You'll notice that a table is going to have an X row and a P of X row. And sometimes, by the way, you write it as columns instead. It could have an X column and a P of X column. Doesn't matter whether you do it vertically or horizontal, but it definitely has to have these two items. Any questions at all on a probability distribution table? Okay, once we have that, then it's time to talk about expected value. So I have a template for you, and this is very important. In fact, I'm going to make it bigger. And here's a template. If many trials are done, then it is very likely that the average of the trials will be very close to the expected value. Okay, any questions on what this says? Okay, let me give you, it's one of the examples I like because I made the news for it. It's always fun. And that is, it was a while back, I actually taught a class called the Mathematics of Gambling. And one of my students, I asked her, what does she do? And, she said, I work at the casino. I said, oh, do you deal? She said, no, I'm a manager of that. I said, oh, you're a pit box? She said, I'm a manager. I said, oh, so you're the floor, the floor manager. They said, no, I'm the manager of them. Oh, you're the full, casino manager. She said, no, I'm the manager of them. She was the Western region manager. And she asked me a very important question, and that is, in her casino, the expected value for the players was negative 10 cents per dollar. And then she said, and we've been playing for months, and our floor, actually, the players are winning on average. And if we're talking casino, it was a busy time. It wasn't COVID time. So many trials were done. And she wasn't even close to the expected value. She was losing money instead of winning money. What do you think I told her? Any thoughts? I don't see y'all jumping in. What do you think I told her when they had done the many trials, very large sample size, and it wasn't close to expected value? Yeah, what I told her is you need to look at the videos. They have videos that watch all the players and dealers. And the next day it came out in the news that there was a big ring and they all went to jail because they caught them. And I was part of it because I kind of convinced her of the math was correct. And basically, if things are random, then if there's that many, you should not be very far from the average. Okay. If you flip a coin, 5 times and get 4 heads, that can happen. Does that make sense? Right? You're supposed to get 2.5 heads. That's the expected value. It's the average. But if you flip a coin 1,000,000 times and get all but 1 head, somebody's cheating. Okay, it means you're cheating because it's just way too unlikely. Does that make sense? So I want to let you know, you're going to be asked in a couple weeks, 2 weeks from yesterday. Let's do. Should I tell you? Let's see, I'll jump in the week 4 quiz. And you're going to have to interpret an expected value. There's a good chance of it. There's some randomness, but you may have to interpret the expected value. See these words in red? Many, likely, average, close to. Those words must be there in your explanation. But don't just say if many, don't just copy and paste this. You have to write it in when you're doing the explanation on an exam. You're required to write it in the perspective of the question itself. So if it was about the casinos, you need to talk about gambling in the casinos. If it was about, car sales, you need to be talking about car and sales. Do you see that? You can't just copy and paste a definition and expect that to be your answer. And that happened to a few of you on the exam where you looked like you just copied and pasted and you didn't refer to what the question was actually asking about. And by the way, questions are randomized, so you all get different questions, but they all are on the same ideas. So expect an expected value question. Okay, I'm not going to spend a lot of time on this formula, but the expected value is equal to mu, which is a summation to xp of x. You're not responsible for necessarily knowing the formula. Any guess on what you're going to be doing? Yeah, calculator. So let's go to the calculator. And that is, you thought mu was the average. Another word for expected value is the mean or the average. But it's a long-term expected average. Do you see, remember in those words, check it out. Do you see in red here? Average. So the expected value is all about what, if many trials was done, then it's likely that the average number of trials is close to the expected value. We are talking about an average. So that's why we use mu. So it's a good question, and it's nice that you noticed it, because we're really talking about an average. So let's go to the calculator. And I'm hoping that you're all going to know what calculator number we need to choose. I tried to make this easy. What calculator? Somewhere between 1 and 15. And I did it in order. Shouldn't be hard. So which calculator to use? Yeah, number 6, because that's expected value, and standard deviation. It's going to compute both. So I click that. So the way I did it here, I did it in a column table. There's reasons, don't worry about it. It doesn't matter if you do columns or rows, but with the calculator, it wants you to do columns. So the x values again, 190, 290, negative 10. Oops. There we go. And then the probabilities were 0.12, 0.08, and 0.8. By the way, if you did accidentally, if you just got that wrong and you did 0.08 by mistake, I tried to set this so that it'll let you know. And you'll see in here probabilities, if you read, must add to 1. Okay, so that couldn't have been right. But if I fix it, get rid of that 0, now they're going to add to 1. So I actually put in a little check on that. So now if I calculate, the expected value is 38. Standard deviation is about 98. Any questions on that? So the expected value is 38. So now let's interpret it, noting I need to have those words many, likely, average, and close to. Okay, and then always read there. We're talking about, this car salesperson for customers. So we can say if many customers. So it's not trials now, it's customers. Come to, 38 is in dollars. Come to test drive a car. Then it is very likely that the average, and it's not of the trials now it's going to be the average profit per customer that the salesperson makes will be very close to the expected value, which was 38, and that's dollars. Any questions at all on this example? Yeah, 98 is also right. So expected value and the standard deviation are always in the units of the survey. Mean and standard deviation are the same as units of the survey. It's one of the reasons why I told you last week that variance is one that you're not going to be interpreting in your project, because the variance, by the way, would be in square dollars, which is like truly meaningless. No one cares about square dollars. That would be the units. So, but the standard deviation and the mean are dollars, because that's the units of the survey. Any questions on this? So what do you think? Do you think this is a good job? Lucrative? Good paying job or not? And I'll let you know, I'm not a car salesperson. You know what I do for a living. Yeah, so it really depends. And I don't know. It really depends on exactly how fast. So if for example, she is doing if she is seeing 2 customers an hour, then that's on average, in the long run, that would be what, $76 an hour. That's pretty good, right? On the other hand, if she only sees, 2 customers, say a customer every 3 hours, then the pay would suck. That'd be less than minimum wage. Do you see that? So it depends. And again, I know very little about car dealers. My actually brother used to do that for a little summer job while I was in college, but I never really talked to him that much about it. Not the details like this. So any questions on this? Okay, the standard deviation, if you remember, was about 98, and I'll round to the nearest dollar, which is probably good enough. Is $98. So with that's a pretty big number. If you look at the expected value, which is 38, 98 is a lot bigger than that. So what that tells you that there's going to be a great amount of fluctuation, because standard deviation is fluctuation, right? How much things kind of go up and down. So if this is your job, you better have a good amount of money in your bank account, because there's going to be days where you lose money, and there'll be other days where you do really well. Does that make sense? So, but if you wait a long time, if you have a good large bank account, then in the long run, you'll be making a solid amount of money. But in the short run, some days you'll have bad days and lose. So that's why you have to have a good bank account. So do you see how important it is to understand both the expected value and the standard deviation? Because it gives you more information. Any questions on this example? Okay. We don't have time to do lots of examples, so I think I'm going to skip this one. And I want to go to the binomial distribution. Okay, and if you have time, maybe I'll do more. But I try to make sure I try to make sure that I go through all the main points, because I also try not to go, I try to do around an hour and a half. And this one should be a little shorter because we don't have a project to talk about. No, nothing too big, but there's still stuff. So here's a new definition, and that is a binomial distribution. When you see the word bi, you know what that prefix means? You all have seen it, and you all should know it. Yeah, that prefix is 2, right? You all know what a bicycle is? And that means 2 wheels, whereas a tricycle would be 3 wheels. So binomial means there's really 2 different possible answers that could happen. Okay. And so it comes from multiple independent trials of a kind of a yes, no, or only two answer question. Okay. So yes, no is the most common. Okay. And it measures the number of yes answers that occurred amongst the big survey. Any questions on that? Okay. And they need to be independent. That's usually not a big deal. That's pretty easy. But you have to make sure it's it's truly a kind of a yes, no question, or where there's only two possible answers. So for example, for stats, for example, at this college, I could say, how are you taking this class? And the answer is online or face-to-face. And we have a group of online students, we have a group of face-to-face students, and that's all we've got. Okay, we don't have hybrid or anything like that. So that would be binomial also, because there's only two answers. But you can always take kind of a binomial distribution. So the trials, if it's not yes, no, you can always turn it into yes, no. So instead of saying what kind of stats are you taking, I could ask, are you taking an online class in stats? And that would be yes or no. And it's really the same question. Any questions on the idea of what a binomial distribution is? Okay, do you think this comes up once in a while or a lot? What do you think? Yeah, all the time. It's a biggie. So let me give you some of the kind of real common ones that have happened recently. What happens when you take a COVID test? What are the different outcomes? If you're coughing a lot and you say, I don't know, so I think I'll take that test. Yeah, either positive or negative. So it doesn't have to be a word yes or no, but there's only positive, negative. There's no like, well, you kind of have COVID. It doesn't work that way. You're either positive COVID or you're negative COVID. So that's an example of something that binomial distribution. So for example, if you randomly selected, 50 people in California and asked and gave them a COVID test, and you counted how many positive tests there were, that would be binomial. Any questions on that? Okay, so here's an example I like to give. Sorry if it's depressing, but it's real. And it hopefully it'll make you guys not a naysayer. And that is, there have been 142 years in recorded history of global temperatures. Okay, not sure if you know that. Okay, but it is. Okay, in the next 20 years, if weather patterns are random, find the probability that at least 10 of them will be in the top 10 of the prior 142 years. Any questions on the question? Okay, so if we look at next year, for example, or this year kind of counts too, because we don't know this year's, full weather yet, because the year's not over. Then the survey question would be, is the global temperature in 2022, will it be in the top 10 of the prior 142 years? Any questions on kind of the survey question? And that's a yes, no question. And in 2023, we'll ask the same question. And in 2024, we'll ask the same question. Any questions on the idea? It's a binomial distribution because the answer to the question is yes, it's in the top 10, or no, it's not in the top 10. Does that make sense? So that's why it's binomial. And what we want to do is we want to look in the next 20 years, how many of them are in the top 10? Yeah, top 10 of the hottest temperatures. Yeah, top 10 is in high temperature. Okay. All right. So let's do this. What is n in this case? So what you're going to have to do is, in practice, when you're answering questions, you're going to have to find these things. What is n for this example? What's n? Let's see, you put in the number n in the chat box, or you can say it. Yeah, and be 20, and it's 20 because we're looking at the next 20 years. We're going to look at those 20 years and seeing how many of those are in the top 10. Is that clear? So n will be 20. What is the probability that any individual year will have a yes answer in being in the top 10? This you have to do a little bit of work. Nothing too hard, though. A little thinking, I'm going to say. What's the probability of being in the top 10 of the past 142 years? If everything's random, we're assuming random. Any thoughts? Okay, I'm not seeing all jumping in. Okay, so one thing to remember from, you're close, 1 over 42, 1 over 162. It's kind of funny. I'm looking at your answers, and it's a combination of you guys. One of you got the right numerator, one of you got the right denominator. So it's going to be, no, it's the opposite. 10, because there's 10 years out of 142. That's the probability of the top 10 out of 142. If you take 142 years and you randomly grab one, then there's a 10 over 142 chance that that's going to be in the top 10. Do you see? Because 10 of them are in the top 10, and the other and 142 are there to choose from. Anyone lost on that? Because I saw a lot of different answers. With the weather's independent, yeah, so if it wasn't dependent, then this wouldn't be binomial. I'm actually going to talk about that in a bit. I'm going to talk about the realistic thing, but that's later. Yeah, but because I said they were independent a while back, assume randomness, which means independent. Okay. Right, it's not 162. Also, it's not 162 because it says prior 142. Do you see? So it's of those 142. Okay. Now, this is something a lot of people have trouble with, and that is the word at least 10. That's very important. So we're looking at the probability of having at least 10. So the symbols for the word at least is this greater than or equal to sign. Everyone okay with that? That's a math symbol, but it's one you hopefully know. At least gives you a greater than or equal to. Okay. Whereas at most would be less than or equal to. Those are some important words. Less than would be a less than sign. More than would be a greater than sign. So it's important to be able to read the words and understand what that means. So x greater than or equal to 10. What we're going to want is, among all the possibilities, what's the lowest number that is greater than or equal to 10? And it's not a trick question. It's supposed to be easy, but let's see if you can get it. What's the lowest number that's greater than or equal to 10? Yeah, that's 10. Okay, of all the possibilities, what's the highest number that's greater than or equal to 10? Yeah, 20, because each year you could be in the top 10 of the 142 years. But if you're only looking at 20 years, you can't ever have more than 20 in the top 10. okay, that made it, that said yes. Do you see that? So we have the low, we have the high, we have n. N, by the way I wrote it in my program is number of trials, and P for probability, okay, is 10 over 142, which, by the way, we're going to need to write it as a decimal. So I'll show you how to write that as a decimal a little bit. Okay, so now what we're going to do is we're going to find the probability. So this is not an expected value question, by the way. So I'm going to go back to the calculator menu, and I'm hoping you can all tell me which calculator number to use. And another hint is I've tried to make these in order. Yeah, there's number 7, binomial probability. So you are responsible for being able to know which calculator to click on. Okay, and what I tried to do is I tried to make it really easy to read. So it asked for the low, and the low was 10. It asked for the high, and the high, if you remember, was 100. The high was 20. The number of trials was 20. We're looking in 20 years. The probability, we need to write as a decimal, is 10 over 142. So I click scientific calculator, and I just type 10 over 142. Again, I try to make it easy, and I could even copy and paste this guy in. So it's however many decimals you feel like. I was use them all because I don't have to type them. And there's my probability. So stop me if you have questions. And then I hit calculate. And what does it give us? Okay, I see the number 0. Does that mean there's no chance of it happening? Any ideas? The hint is a little tricky. I don't see all jumping in. Okay, what that really means is that to the number of decimal places that the computer can handle, it rounds to 0. So it might be 40 decimal places before you get to something that's not 0. So it's as close to 0 as you can imagine. Does that make sense? Whereas if this had 0.3, you'd say there's a 30% chance. But there's basically nearly 0 probability. So let me ask you, in the past 20 years, so from the past 20 years we have recorded, so in 2001 to 2020, okay, how many do you think were in the top 10? In the world? So in those 20 years, so in the last 20 years, how many do you think were in the top 10? Okay, at least 5, definitely at least 5. Actually, I think it was 12 or 13. Most of them. So what that means when you get a number that is amazingly close to 0 as a probability, but then it happens, what should you do at that point? And this is really important because this is what this class is all about. And we're going to be doing this in a deep way for weeks later in the class. Any thoughts? If I don't see you jumping in, so let me tell you, you would say it's so unreasonably small a probability that something's wrong. And by the way, what's not wrong, I did not use the calculator wrong. Okay, that didn't happen. I used it right. It wasn't the measurements of, of the world temperature reading people. Let me tell you what was wrong. Right here. Assume randomness. Okay. And that is, in the last 20 years, our weather is not random. What's happened in the last 20 years? Hopefully you all know. Zero change? No, we've had change. We've had change. That's what I'm saying. Something's wrong. What? Yeah, we've had an increase in temperature. And the reason we've had an increase in temperature, from all the scientific evidence, is more carbon dioxide in the atmosphere. So it's not random anymore. Random would mean now is the same as it was before. So anything could happen, but it's not, because our sky's not the same. We have more carbon dioxide. And this is what you call using statistics to basically show something is true, to provide evidence that something you think is true. By the way, this isn't the first time I've done this. I've been doing this for 25 years. 25 years ago, the top 10 was not in the last 20 years. But lately we've been there. And so this is something that I've actually been noticing for a long time now. So it's a little scary, but we're there. And this is basically a very, very, very strong evidence that we have global warming right now. Okay, any questions on this example? Okay, I think, let's see with time. Yeah, I think I need to skip this one, but I do want to, I think I'll read this. And actually, I think I did this a while back, so maybe I should change this because it's not 42%. Maybe I'll even ask what percent of Californians are vaccinated. And it'll probably say COVID. There we go. So California, 84%. So let me change it, because since I copy and paste this from last time, it's been now 84%. Okay, so I'm not going to actually do the question, but I want to write down a few things. Just going to write down the important things you have to know. So as of today, 84% of Californians have received at least one dose of COVID-19 vaccine. If 15 randomly selected Californians are surveyed, what's the probability that between 5 and 10 of them have received at least one dose? So what I want to do, I'm not going to actually solve the whole problem, but I want to write down what you put in the calculator. What's the low? Can you tell me? Not a trick question. It's easy. So what's the low? Yeah, low is 5. What's the high? Also should be easy. That's 10, because between 5 and 10, the low is 5, high is 10. What's the trials? That'd be 15, because 15 were selected. And what is probability? Not 84, it's 0.84. It always has to be written as a decimal, not a percent. So that's important. But you get the 84 is a good idea, but don't forget to make that decimal happen, or the calculator will get mad at you. Does that make sense? Okay, let's look at B. How about at least 7 of them have received at least one dose? What's the low? That'd be 7. What's the high? Yep, 15, because if everyone did it, that's 15. And trials equal 15. And probability is the same. Probability is not changing, neither are trials. Okay, and hopefully the calculator is not hard for you to use once you do it once. If it is, let me know. Maybe I'll make it better, but you have to give me suggestions. Okay, so less than 9 of them have received at least 1 dose. What's the low? That's 0, because 0 is the lowest number that could be less than 9. What's the high? Not 9. 9 is not less than 9. 15 is definitely not less than 9. What's the biggest number less than 9? 8. You know, for a number of people, 8. Trials equals 15, and P equals 0.84. Okay, next is exactly 6 have received at least 1 dose. What's the low? So I want to make sure you can understand some of this language. What's the low in this case? Once I show you, it'll be really obvious. What's the lowest number that counts for exactly 6? Yeah, 6. What's the high? Yep, 6 again, because the highest number that counts exactly 6 is also 6. And then trials is equal to 15, and P is equal to 0.84. Any questions on this example? Okay. And hopefully you're okay with knowing how to put in the calculator once you have the numbers. You just put the numbers in and hit calculate. Any questions on this example? Okay. So let's do continuous distributions. So remember, continuous distributions, you can't list all the possibilities. So one thing I want to give you a heads up on, when you have a continuous distribution, you cannot write a probability distribution table. Because if you can't list all the X's, how do you write a table? There's too many. Do you see that? So instead, what you tend to do is you draw a graph of what's called the probability distribution. So that if you look at between any 2 numbers on the x-axis of that graph, the area under the curve between those numbers will be the probability of being between those numbers. Okay, I want to let you know that almost all of you will have no chance with this kind of picture in finding this area if you don't have my special computer. Okay, it is brutal. Okay, just let you know that. But, and I've said this before, if you want to come to office hours and be tortured, I'll come and show you. But beware, because it's very difficult. Okay, so this particular type needs a lot of heavy math. But does that mean it can't be done? Okay, you need to know that the area between the 2 numbers below the graph is the probability. That's what you need to know. Okay, that is important. Okay, so for one thing, if you take the area all the way from negative infinity to infinity, what are you going to get? That one you should all be able to tell me. Yeah. So for example, let's say this represented the distance you live from our college. And I said, what's the probability that you live somewhere between negative infinity miles away from the college and infinity miles away from the college? What's that probability? If you don't like infinity, you can call it a trillion or something. What's the probability that I grab someone and they live between negative a trillion and a trillion miles away from here? It's 100% chance, right? So the area under the whole curve will always be 1. Also, the curve can never go below the x-axis because you can never have a negative probability. Is that clear? The curve can be higher than 1, but you just can't have an area bigger than 1. If it's higher than 1, it's going to go 1 and then come right back down real fast. Any questions on that? Okay, so that is a continuous distribution. All right, because doing this and finding the area of this sucker, I told you, is like brutal. There is actually one shape that you all should know how to find the area of when it's coming like a curve and under the curve. What shape is that? Between two numbers. The hint is it's pretty easy. You all know it. Circle's a good idea, but you don't, my guess is most of you don't know how to find the area of a circle between two numbers when it's not the whole circle, when it's just like a little strip of a circle. That's actually kind of hard. Yeah, rectangle. So a rectangle is something that you can find no matter what the width is, because who remembers what the area of a rectangle is? The formula. If you have a rectangle. Yeah, length times the width. Okay, I'll often use base times height because L for me, when I write an L, it looks like a 1. So I'll use B and H, but you can use L and W if you want to, whatever you like. Does that make sense? I've just found that my L looks too much like a 1. It gets confusing. So I use B and H. So hopefully that doesn't, cause you problems. So we call that, when that is the shape, we call it a uniform distribution. So here's the definition. A uniform distribution between A and B is a distribution such that any two given intervals of length k that is contained in AB has the same probability of occurring, and any interval outside of AB has 0 probability. Okay, the distribution curve is a rectangle. Now, this is important because we're going to be doing this with another distribution also. We write out x, and who knows what this little thing is? It's on your keyboard, by the way. Anyone know how to say it? Yeah, tilde. Wow, somebody knows. Usually no one knows because I always ask, and usually no one has any idea. Yeah, it's tilde. It's also the ñ, if you know Spanish. It's the thing on top of the ñ. But the way you read it is has the distribution. So in this case, x has the distribution of being uniform, or you can also say x has a uniform distribution between A and B. Any questions on that? I do want to let you know that the uniform distribution is not the most important distribution. It is important, but definitely not the most important. But it is the easiest to just do. So the reason why we do it in this chapter is so you get an idea, this whole area idea. We can do it. Otherwise, you can't do it, just by looking at it with base times height kind of thing. Any questions on what a uniform distribution is? Okay, let me give you an example. Okay, suppose that the time that students spend with a math tutor, that could be Braulio, okay, is uniformly distributed between 10 and 120 minutes. By the way, if I say suppose, it means I'm totally making it up, but any other distribution is going to be too hard to do. Okay. Well, the first thing we write x tilde u 10, 120. Any questions on writing that out? Okay, so now part A. If a randomly selected student who used a math tutor is observed, find the probability that the student will spend between 30 and 70 minutes with the tutor. Any questions on that? Okay, I think I want to do this for now. So let me show you the steps, and I'm going to do them instead of just have them there for you. The first step is to draw the picture, which I drew because it's easier to do ahead of time. So I drew the picture, and again, uniform distributions are rectangles. It goes from 10 to 120, because that's what this says. The height of the rectangle, we don't know. It's h. Do you see that? So I'm just going to say height is h. I don't know what it is. Give it a letter. Sound good? We will find it. But right now, just you don't know what it is. It's not told. All right. What is the probability that if you randomly select something, it'll be between 10 and 120? The hint is it's very easy. Yeah, it's 1. It's 1. It's the probability because that's the only possibilities. That's what uniform means. It can't get less than 10. It can't get more than 120. So the probability of being in all the possibilities is 1. But 1 is also equal to the base times the height. I'm going to use BH. I hope that's okay. What is the base of this rectangle? How long is it? Yeah, it's 110. And I'm going to do the math for you guys too. It's 120 minus 10. Because it goes from 10 to 120. Well, and the height is h. We don't know what it is, so it's just h. That's equal to 110 h, which let me just rewrite is equal to 1 because we have it equal to 1. And I want to solve for h, very basic algebra. By the way, there's a little bit of algebra in this chapter, but not too bad. What do I have to do to get h by itself if I have 110 times h equals 1? What is h? I don't see y'all jumping in. I promise the algebra is not hard, but you have to do it. Yeah, you divide by 110 on both sides, and you get h equals 1 over 110. Any questions on that? Okay, we're not done yet, because remember, we haven't even looked at these numbers here, but it's time. So now we want to find the probability the student will spend between 30 and 70 minutes with the tutor. So now I'm going to draw more of the picture. So I'm going to draw the same rectangle that has everything, and I want the probability that it's between 30 and 70. Any questions on that? All right, well, the probability that 30 is less than x, which is less than 70, is equal to, well, it's a rectangle. It's that shaded in rectangle, which is area is base times height. Now we just do it. How do we get the base of this? Of our shaded rectangle. What's the base? Add 70 and 30, not quite. I don't like your word add. Subtract 30 from 70. So we're going to take 70 minus 30 will give you the base. Do you see? If you start at 30 and you have to get to 70, you got 40 more to walk. Does that make sense? The height was 1 over 110 because that we already calculated. And that's equal to 40 over 110. Or if you want 4/11ths. Any questions on this probability example? I do want to let you know, it turns out that, this may look hard, but unlike chapter 3, the problems are basically all the same. I mean, they're not all seeing a math tutor, as in how many minutes to see a math tutor, but the technique is just going to be the same over and over again. So once you understand this one and do a couple examples and realize they're all the same, then you just do it. So you write down base times height, you plug in, you find your height first using the general, full rectangle. And then you find the probability that you're between two numbers, base times height. You write down the right minus the left times the height you found, and there's your answer. Any questions on that? All right, the next question is find the first quartile for the time that students spend with a math tutor. Who remembers what first quartile means? Yeah, it's up to the 25th percentile, which means that the probability of being lower than that number is 0.25. So I can draw a picture like so. So I have my rectangle that goes from 10 to 120. I don't know the first quartile. If you don't know in math, you just call it X usually. You can call it Q1 if you want to. X is fewer letters to write. Okay. But we do know that the area to the left of X is 0.25. Anybody lost on what I just did? Okay, so now we just do what we did. We know that the area is 0.25. That's equal to the base times the height. The base is going to be the right minus the left. Well, in this case, we don't know the right. The right is X minus the left, which is 10. The height is the same height. It's the same big rectangle, 1 over 110. And it helps sometimes just rewrite equals 0.25. Anybody lost on what I just did? There's kind of two kinds. There's find a probability, and that's what I did first. And the second kind is like find a percentile or a quartile, that type of thing. All right. Now you may not like what I'm about to say, but now you have to do algebra. So what I like to do when I'm doing algebra is I do the order of operations backwards. So if you have this X, the first thing you do is subtract 10. And the last thing you do is divide by 110, which means the first thing I do to get X by itself is to undo the last thing. And the undo dividing by 110 is multiplied by 110. So I'm going to multiply left and right by 110. And what I get is X minus 10, because the 110s cancel, is equal to 0.25 times 110. Now, how do I get X by itself? So what does X equal now? What do I have to do to both sides? I have x minus 10. I don't want that minus 10. Promise it's not that hard. So what do I do to both sides to get x by itself? Yeah, I add 10. That's how you undo subtract 10. So we have x is equal to, we still have the 0.25 times 110, and then plus 10. Okay, you could do it in your head if you want. You could put in your calculator if you'd rather also. And what is was it 37.5? But you can also just do it this way. And it gives you 37.5. So you don't have to do it in your head. You're always allowed to use a calculator. Any questions on that? So 37.5 will be the first quartile. Any questions? I'm not going to do all of these, but maybe I'll hang this here in case you want to do some practice. But here's a whole lot more you could do. Okay. But I can only do so many because I'm looking at the clock. We only have 10 minutes left and we still have a little bit more to do. Okay. All right. So here is a big theorem. And that is if x is uniformly distributed, that's how you read this. So if x is uniformly distributed with low a and high b, from a to b, then the mean is a plus b over 2. That should be kind of obvious because let's kind of look at this example. If this is the distribution, then the average should be right in the middle. Does that make sense? And the way you find the middle of two numbers is add them up and divide by 2. Any questions on that? So if we have a uniform distribution, the mean, to find the mean, you just add the low and the high and divide by 2. On the other hand, the standard deviation is the square root of b minus a quantity squared over 12. Okay, and I will let you know that you're not responsible for understanding why that's true. That one takes a lot of calculus, which I can't do in this class. But again, if you want to be tortured, you can come to my office hours and ask, and I'll show you. But it's calculus. So, but what you do need to know is to have this. Okay, and again, you're not required to memorize any formulas, but you are required to know when to use one, know how to use it, and have access to it. So some kind of note sheet that you're working with, that kind of thing, because you're allowed note sheets for exams and that type of stuff. So what I recommend is have these two in a little formula sheet so you can easily get to it. Any questions on this big theorem? Okay, so now we know how to find a mean and a standard deviation. So let me give you an example. Okay, so suppose that the number of ounces of water that people drink from a drinking fountain is uniformly distributed between 1 and 8 ounces, and that the number of ounces of water that students use to fill their bottles in the drinking fountain is uniformly distributed between 4 and 16 ounces. Okay, you watch Thorne take a 2.5 or 2.5 ounce drink out of a drinking fountain, and Preston fill his water bottle with 5 ounces of water before he runs off to class. Question is, whose water usage is more unusually small compared to the rest of the people who use a fountain for the corresponding water usage? Any questions on the question? Okay, I have a question for you. How do we measure how unusually small something is? Any thoughts? Maybe you can put in the chat box or say it. How do you do a measurement of how unusual something is, unusually small? Okay, let me give you a hint. Put in the chat box. All I want is a one-letter answer. With one letter, you can talk about how unusually small something is. Sometimes there's a word after the letter, but you can just give me the one letter that we've had in our class already. Should be quick to type. X, good guess, but nope. Nope. X. I like this. Yep. Bralia's given a little hint. Something dash score, z-score. Okay, the z-score gives you a measure of how unusual something is. Very important for your projects, by the way. Okay, so what we want to do is we want to find the z-score for Thorn's drink, and we want to find the z-score for Preston's drink. By the way, these are two of my former students from a long time ago. I had a student named Thorn and a student named Preston. So I just used their names. Okay. So now you need to know how to find what is the formula for the z-score. Hopefully you remember. If you don't, I'll pop it up. I think I have it here. Okay, so if you didn't remember, z is equal to x minus mu divided by sigma. I don't know if you remember that, but that's an important formula. It's a z-score formula. So now let's do it. So we need to find everybody's numbers. So Thorn's x. What's Thorn's x value? Yeah, 2.5. Then we got to find Thorn's mu. And to do mu, I need to insert an equation and get a mu out of it. There we go. What's Thorn's mu? And the hint is Thorn is drinking out of the drinking fountain. And it's uniform distributed between 1 and 8. Here's a little hint. I'm going to make a fraction. It's between 1 and 8. Do you remember? The formula for the mean is A plus B. Oh, sorry, A plus B, which is 1 plus 8 divided by 2. Then we got to find Thorn's sigma. So that had a messy formula. And that was, if you remember, it was a square root. And then it had a fraction. And let me just pop it up here so you can all see it. It was b minus a squared over 12. So that's going to be 8 minus 1 squared over 12. Any questions on that? And by the way, that's square root of 7 squared over 12. This is one of those. We want to put it in. So square root of 7 squared over 12. And around 2.02. How about? Do a couple decimals. Any questions on that so far? Okay. Oh, I didn't do this one. 1 plus 8 over 2. That one I can do in my head. That's 9 halves or 4.5. Okay, now we're ready to get Thorne's z-score. So now we can say z is equal to, now we're going to have x minus mu over sigma. So x was 2.5 minus mu was 4.5 over sigma, which is 2.02. Okay, so 2.5 minus 4.5 over 2.02. So 2.5 minus 4.5, and the parenthesis divided by 2.02. And it's just around -1. Okay, within a decimal or so. Any questions so far? Okay, so its z-score is -1. It's about 1 standard deviation away. And then let's do Preston's. I think it'd be easier if I copy and paste and change the numbers. It's the same idea. Now, Preston, we can see with 5 ounces. So Preston did 5 ounces. So that's x is just 5. The mean now the low and the high for Preston. Preston's doing a bottle, and that's between 4 and 16. That's right here. So now we're going to have 4 and 16. 4 plus 16 is 20. 20 divided by 2 is 10. Sigma is going to be 16 minus 4 squared over 12 with a square root. Okay. Which, if you do a little math, it's 16 minus 4 is 12. 12 squared over 12 is actually 12. And it's the square root of 12. So it's a little easier to type in that way. So it's just the square root of 12. Which is about 3.46. So then the z-score will be 5 minus 10 over 3.46. So now we just do that. And we get about -1.45, rounded to 2 decimals. All right, now we're able to answer the question. Thorne's z was -1. Preston's was -1.45. So whose water usage is more unusually small? Looking for a name? Whose water usage is more unusually small? Yeah, Preston's. Unusual. Any questions on that? Okay. So the good news is the last thing I have to do is a secret word. The secret word is horizontal. And it's horizontal because if you have a uniform distribution, then that means the curve is just a horizontal curve or a horizontal line. So that's the secret word. Make sure you write it down so you've got it, and then do the secret word quiz before Sunday so you can get credit and don't have to send me 5 pages of notes. And hopefully you all have it. So that's the secret word is horizontal. So hopefully you now can do chapter 4 and chapter 5. I want to remind you, I'm here in office hours on Tuesday. I won't be on Wednesday. I'll be gone Wednesday, but I'm back on Thursday. Okay, so I'll be around to help out if you have questions. That could be about the project. It could be about the exercises. Braulio has lots of hours also, whole lot. So, please. I don't know if I've done that, but you have the YouTube video, so you can watch everything on this by just scrolling forward to backwards. I probably could share it if you send me an email if you really need it. But it's not private or anything. But I am going to stop the recording. Where is my thing? There it is.